So today we are looking at chapter 1. It's an introductory chapter, primarily concerned about how we measure things in physics, but some brief introduction on top of all of that. So we have, again, if you want to look at the introduction, it's in the book. So let's talk about how we measure things. In physics, it's really important to have units of measurement by every number that has one. If you measure a distance, I need to see a unit beside it. Did you measure it in feet or inches or meters or miles? You don't just write down a number. So prior to the French Revolution, measurement systems were colorful. An inch was the distance between the two joints on your thumb. A yard was the distance between your nose and your outstretched arm. Your foot was a foot. So you sort of carried your own measuring devices with you. But with the French Revolution, there was a push to standardize measurements. And we started out with a distance measurement defined as the meter. And it is 1/10,000th the distance from the equator to the North Pole. Well, we don't usually define it that way anymore. That was an initial definition of it. But now we define it in terms of the length that a path of light is going to travel in a vacuum in this little teeny tiny fraction of a second. So in our class, we will predominantly use the metric system, which is sometimes called the SI system. With units of measurement, you have two types. You have fundamental units, and they have to be defined. You pick them. We pick the second to measure time in. We pick the meter to measure distance in. But you also have derived units that are a result of calculations. So force is a calculated value in physics, and that means the unit that we measure force in is also a calculated or a derived unit. So it's a result of the actual physical calculation. We measure force in newtons. We'll get to that in a later chapter. And a newton is a kilogram times a meter divided by a second squared. So a newton is a derived unit. So sometimes you just have to make them up. Those are the fundamentals. And sometimes you just have to calculate it. That would be the derived units. So within the metric system, we have two subsystems. You have the MKS and the CGS. MKS is another name for the metric system or the SI system. Distance is measured in meters, mass is in kilograms, and time is in seconds. In the CGS system, which is sometimes called the Gaussian system, distance is in centimeters, mass is in grams, and time is in seconds. They tried to group small units together with these two systems. So a centimeter is less than half an inch. It's about the width of my fingernail. A gram is about the size of a paper clip, and you know how long a second is. With a meter, it's a little bit more than 3 feet. It's actually approximately 39 inches. A kilogram is roughly 2.2 pounds, so about the size of a big bag of powdered sugar at the grocery store. So again, sort of larger units in the MKS, smaller in the CGS. And it used to be in physics, we would go back and forth. If what you were measuring was a very small thing, you probably use CGS units for it. If what you were measuring was really large, you would use MKS. Now we use MKS units unless you're told not to. So we will probably stick with MKS units with a few exceptions along the way. It is really important not to mix subsystems. Do not mix subsystems. So you cannot measure a distance in meters and a mass in grams and calculate with them. And I will emphasize this as we go along. You have to keep them separate. So the metric system is really great because it gives us a lot of prefixes. It's really easy to go between a centimeter and a meter or a gram and a kilogram. Unlike the British system, we're going from inches to feet. You gotta do some math, and it's a little complicated. So metric system's great because it's all the power of 10. The three prefixes we'll start out with are kilo, centi, and milli. Kilo is abbreviated lowercase k, don't turn it into a capital, and it means to multiply the value by 10 to the third, so 1,000. Centi is lowercase c, and it is 10 to the minus 2, or you multiply your number by 1/100th of the value. And milli is lowercase m, and you multiply the value by 1/1000th, so 10 to the minus 3. So in other words, as an example, if you took a kilometer and dropped the k, you would have to add the multiplying factor of times 10 to the third. So 1 kilometer is the same as 1,000 meters. A milligram goes the other way. It's 10 to the minus 3. So 1 milligram is 0.001 grams. You'll notice when I write a decimal number that is smaller than 1, I don't just put the decimal down and then the digits. I write a 0 and then the decimal point. And that's because decimals sometimes get lost. They're small. But if I see a number that starts with a 0, I know there's got to be a decimal point in there somewhere, and I look for it. So you need to be really careful about your decimal points. All right, let's look at the table. This is from your book. Remember, we've got a nice online version of the book that's free. So you have the prefix and its symbol and its value and some examples. Notice some of the symbols are capital letters, some of the symbols are lowercase letters, and there are even some symbols, like for micro, that are Greek letters. So as we go along, we'll introduce the ones we need to know. Let's look at converting. So when we convert from one type of unit to another, some people find this really easy. They can do it almost in their heads, but there are a lot of us that need to write it down. So let's do an example. Let's convert 123.7 grams into kilograms. You know that 1 kilogram is 1,000 grams. You need to be able to write that down. So to start our problem, we write down the 123.7 grams and an equals sign. Then I open a parentheses and write it down again. And then you'll notice I've got a bigger parentheses that takes up 2 lines. I would normally, if we were writing it on paper, I would want this 123.7 grams to line up with the numerator on this fraction. So I really would want this whole thing to be down a little so the 2 numerators line up. And you wouldn't put these little boxes in there. That's just the equation editor I'm using. So we have it written down. This in parentheses, the fraction, is going to be my conversion factor. So I know I have grams, and that's what I want to get rid of. That means I need grams in the denominator. I know I want to be left with kilograms, so kilograms will go in the numerator. So you can see on this next line, that's exactly what I've done. Grams in the denominator to cancel this grams, kilograms in the numerator because that's what we want to be left with. And then on the next line, we put in the numbers. So I go back to what I know. I know that 1 kilogram is 1,000 grams. So 1 goes with the kilogram, there it is, and 1,000 goes with the grams, here it is. And now I can do the math. 123.7 multiplied by 1 is 123.7, and then divided by 1,000 gives me 0 decimal 1237, and the answer is in kilograms because the units of grams canceled each other. Now, when I do this for myself, I don't normally use this many lines, but I wanted you to see the steps without having to watch another little video. And so I probably would write all this on, I would write down what I know, And then all of these calculations would end up looking like this as I filled things in, and then I'd have my answer. A lot of people can do this sort of conversion in their heads. If you're one of them and you always get it right, great for you. But if you tend to make mistakes, what you need to do is set it up with a fraction as your conversion factor and just go through the process I've outlined. So you should notice that let me scroll down. You should note that I could go from grams to kilograms by just moving the decimal 3 places to the left. I find that when students just move the decimal point, a lot of them go the wrong direction. So if that's the way you want to go, be really, really careful. And if you start making mistakes, all I'm going to tell you to do is you need to go back and do it like this. You need to set up the fraction, put in the units, and put in the numbers, and do the math. All right, let's talk about units. Units can be reduced to their simplest form using algebra. We're good with algebra with numbers, but most of you haven't had much practice taking the units of measurement and changing them based on math principles. So let's look at the example. 80 meter kilogram seconds divided by 2 meters per second squared. What does it give me? Well, 80 divided by 2 is 40. We've got that. But we still got meter kilogram seconds divided by meters per second squared. We need to simplify that. So what we do is rewrite it so that, I'm sorry, I guess we need to look at this. So when you have a fraction in the denominator, you invert and multiply. So this meter per second squared is going to get turned upside down and multiplied by the unit in the numerator. So remember, it was meters per second squared in the denominator, so I flipped it. Now it's second squared over meters, and it's multiplied by what we started out with in the numerator, meter, kilogram, seconds. And I just wrote it over the number 1 so that we could keep straight what was in the numerator and what was in the denominator. So we look at this. A meter in the numerator cancels a meter in the denominator. They go away. So this meter in the denominator cancels this meter in the numerator. So now what do we have? We have a kilogram second over 1 multiplied by a second squared over 1. Okay. Kilograms don't have anything to multiply by it or change it, so we write it down. A second multiplied by a second squared is a second cubed. And 1 multiplied by 1 is just 1. And then we don't actually have to, if anything over 1, you can just drop the denominator. And so our answer is 40 kilograms seconds cubed. Now I could have gone from the initial calculation to the answer, but I wanted to emphasize this invert and multiply when you have a fraction in the denominator, and how important it is to write your fractions on 2 lines so you can see what cancels and what multiplies. So conversion changes the units that we're measuring in without actually changing what you're measuring. If you were going to measure the width of my hand, you could use a ruler and measure it in inches. You could use a ruler and measure it in centimeters. You'll get 2 dramatically different answers, but my hand is still the same size. So conversion is really multiplication by the number 1. The fraction that we come up with actually is a value divided by its own equivalency. So I will give you that 1 inch is 2.54 centimeters. I will give you that 1 mile is 1.6 kilometers. I will give you that 1 kilogram is 2.2 pounds. We'll talk about later why I say when gravity is 9.8. But you have to know the metric ones, the centimeters to meters, or grams to kilograms, or meters to kilometers. You have to know how to do those powers of 10. So let's do one. So we've got a mile. We know that 1 mile is 1.6 kilometers, and we want to convert 3 miles into kilometers. So 3 miles will be 3 miles multiplied by our conversion factor. We've got miles in the numerator. We want to cancel it. So in our denominator, we'll have to have miles. we know that we can convert miles to kilometers using this information. So I'll put miles in the denominator, kilometers in the numerator, and we should be good to go. So miles in the denominator, kilometers in the numerator. You go back and look at where we started, the 1 went with the miles, so that's why there's a 1 here. The 1.6 with the kilometers, that's why there's a 1.6 in the numerator. And now it's just 3 multiplied by 1.6 and then divided by 1, so it's just 4.8. And the units, we've got miles times kilometers divided by miles. The miles cancel, and you'll just be left with kilometers. The miles cancel, and you're just left with kilometers. So I would probably have gone from this step to the answer. But if you need to write down more steps, you should do it. Let's do a second example. So this is our 4th one for the chapter. I want to convert 2 meters into inches. So we need to remember that 1 meter is 100 centimeters. You're supposed to know that. And we will be given that 1 inch is 2.54 centimeters. So how do we set it up? So 2 meters, which is what we were given, equals 2 meters multiplied by its conversion factor. We've got meters in the numerator, so we need to have meter in the denominator because we want to get rid of it. But we don't have a meter to inches conversion, so we're going to have to do centimeters first. So meter in the denominator, centimeter in the numerator. The 1 goes with the meter, the 100 with the centimeters, the meters cancel. 2 times 100 is 200. 2 meters is the same as 200 centimeters. I can do that one in my head. If you can, there is no reason for you to write down all the steps. You can just write down that 2 meters equals 200 centimeters. Now we have to convert that to inches. So this is our step 2, if you will. So 2 meters is 200 centimeters multiplied by our conversion factor with centimeters in the denominator and inches in the numerator. Again, because we got centimeters and we want to get rid of them. So if we have them, then to cancel them, we have to have them in the denominator of our fraction. And if we look back, we know the 1 goes with the inches and the 2.54 with the centimeters. So 1 with inch and 2.54 with centimeters. And now we do the math. So 200 times 1 is just 200, divided by 2.54 is 78.74 inches. Now, we started out with only 2 significant figures. Some of you will want to round this off to 79 inches. I don't like that in physics. Normally, we assume we've probably got more significant figures because we almost never measure something and then that's the end of it. We're almost always going to do something more with it. So I almost always look to the units to the right of the decimal. Here we had 1. I would keep at least 1 unit to the right of the decimal. I would probably round it off to 78.7 inches. Please don't round off a lot. If you're going to round off, be conservative and keep maybe 1 more digit than you might normally. There are some homework problems for you to look at. These are in the back of chapter 1 in your online textbook. In addition to that, you'll want to look at these 3 conversion factors. So we'll stop with this. You should work on your homework and your study guide questions, and then there'll be another video.